Today we're going to start with factoring out a greatest common factor. As we're thinking about the greatest common factor, it's important to realize that that's something that every term in our expression has in common. So we're going to look at each term of our expression, and we're going to decide first what factors each term has, and then what factors does each term share. So we begin with 12a cubed b. And as we're looking at 12a cubed b, we see it can be broken down into 12 and a cubed b. Those two things multiply to get us back to the original term. And then 12 can further be broken down into 4 times 3, and the 4 can be broken into 2 times 2. We use this tree method to show us every place, every factor that would get us back to 12a cubed b. Now a cubed b is easy to break up. First it's a cubed times b, and then there's 3 a's. Sometimes we don't even need to do the tree for the variable side of our term, because we can see there's 3 a's just from our exponent on the a, and there's 1 b from our lack of an exponent on the b. We've broken down 12a cubed b as far as it can go, and now we got to do the other terms. So quickly here as we go, we know that 6ab can be broken down into 6 times ab. 6 is 2 times 3, and ab is of course a times b. 18ab squared is going to be 18 times ab squared, and then that's 6 times 3. 3 is 3 times 2, and ab squared is a times b squared, and b times b. Okay. Our last term is 18 times a squared b, and then 18 can further be broken down into 6 times 3 and 2 times 3. A squared b is of course 2 a's and a b. Now that we have all of our terms broken down as far as they go, we want to write it in prime factorization, and I'm going to do that down here at the bottom. So we know our first term is 2 times 2 times 3 times a times a times a times b. That's everything that's at the leaf of our tree diagram. Everything that's at the leaf of our tree, the very edges of our tree diagram. We do the same thing with the rest of the terms. Okay, and that last term is a b. Notice we used everything that was at the leaf, and now we've got one nice expression. It's 2 times 2 times 3 times a times a times a times b minus 2 times 3 times a times b plus 3 times 3 times 2 times a times b times, and you can see. Okay, well now we're ready to go on and see what things each term has in common. So as we look at that, the first thing we see is that every term has a 2. Okay. Now, some terms have more than one 2, the first term there, but because all the terms don't have more than one 2, we can just lift out 1 2 from that first term. The next thing that all terms have in common is a 3. Again, that third term has more than one 3, but because the first two terms just have 1 3, we can only take out 1 3. Our last thing that we have in common is a, and a appears in every term, and b appears in every term. So what we can take out is 2 times 3 times a times b. So as we take that out, it's coming out of every term, and we're left with what's inside. We're left with what's inside of each term. We're left with what's inside of each term, and we see that's 2 times a minus 1 plus 3b minus 3a. We can simplify everything there. So how we got our statement in white here is 2 times 3 times a times b is 6ab. 2 times a is 2a squared minus 1 plus 3 times b is 3b. and 3a becomes 3a. This is our final answer. Okay, so we've looked at one example, and I would like for you to go ahead and factor this polynomial out by yourself. Okay, so please right now go ahead and pause the video. Go ahead and pause the video, and when you're done, hit play. So again, go ahead and pause the video. Okay, hopefully you've solved the equation by now. The correct answer to this equation is 3x times 3 plus x minus 2x squared. If you have any questions about how we got that, please make sure that you ask your teacher. Okay, now I'd like for you to go ahead and find the mistake. We're going to use the polynomial 3z minus 21xz to the fourth. As we use this polynomial, I'm going to work it out as far as it goes. I'm going to completely work the polynomial out, factor it out, but I'm going to make one mistake, and I want you to find that one mistake. So here's we're looking at what's going on. We want to break down 3z into 3 times z, and we're breaking 21xz to the fourth as 21 times xz to the fourth. 21 further gets broken down into 3 times 7. Xz to the fourth gets broken down into x, and then we have 4 z's. So our prime-nomial factorization is going to be 3 times 2 minus 3 times 7 times x times z times z times z times z. Okay, we're ready to find what's common. And what's common to both terms is that 3. So we're going to pull out a 3. There's also a z that's common to both terms. We pull out a 3 and a z, and when I do that, the things that I have not circled is a 1 from the first term and a 7x from the last term. So what went wrong as we worked through this problem?